Alright guys, we're going to start simplifying rational expressions, which is going to be a new skill that we're going to be working on. But we're going to start off slowly with some basic rational expressions that involve only monomial factors. Right, so that means just one term. Monomial meaning one term. We will get into binomial factors and we will occasionally see some trinomial factor situations, but we're going to start off slow. So we're going to be using the GCF method. We'll probably use some double bubble and some grouping, but we're starting off with just some very basic factoring skills. So whenever you're simplifying, you want to factor first. All right, so what you're going to do is you're going to take every term that's involved and you are just going to factor that if you can. So starting with example A, we've got a numerator that can definitely be factored and a denominator that definitely cannot, because this is just one term, right? So in my numerator, I think my GCF, if I use a GCF method here, would be 13x to the third. And if I factored that out of both of those terms, I'd be left with a 2x squared minus 3. My denominator cannot be factored, it's just one term, but I already have a 13x squared down there. So this is what I was hoping to realize, is that there would be something that is common in the numerator and denominator. And that's going to be the second piece to simplifying these. You're going to cancel any ones, right? So if we really think about what we have here, and over on the side I'm just going to write this as 13x squared times x over 13x squared. And the reason I'm doing that is because this here is this. We're just going to look at that piece right now. I can see 13x squared over 13x squared as just a 1 over 1, right? 1 is the same as 13x squared divided by itself. So when I cancel, I'm replacing with 1s, and that's just going to leave me with that x behind. So what I'm going to end up with when I cancel that above, cancel my 13s, cancel x squared, it's going to leave me with x to the first. My final answer then is just going to be x times 2x squared minus 3, or 2x to the third minus 3x. So notice all I really did here was just factor and cancel out ones. All right, we'll do the same thing in example B. In example B, can't really do anything with the numerator. It is a monomial, but the denominator I can factor. I could use the GCF there. So I'll have 17x squared all over. My GCF is, I think, 17x squared here. So that's going to leave me with 2x minus 1. And in this case, I'll be able to cancel all of that. So I'll be left with 1 over 2x minus 1. And that's something you want to be careful of here. Remember that when you cancel, what you've done is you replace those things with 1s. That's not a 0 in the numerator. That's a 1, because this has been canceled and reduced to just 1 over 1. All right? Moving on to a slightly more difficult case. We do have two binomials here, and we're looking for a GCF in my numerator. I think I have a 15 and a 45, so the number will be 15. I'll take as many A's as I can. I'll take as many B's and as many C's as I can from my numerator. So when I rewrite this, I'm going to write it as 15A B squared C. And that's because I can take at least that much from each of those terms. And if I take 15A B squared C from the numerator, I'll be left with a 1c squared in that first term, and I'll be left with a 3a in that second term. So what that is that's me taking this, dividing it by 15a b squared c, and then doing the same thing here. And that's leaving me with c squared plus 3a. I'll do the same thing in the denominator, but this time I think my GCF is a little larger. It's a 30, and I could take an a squared and a b squared. No c's. Notice this term does not have any c's, so I can't factor out a c. So I gotta leave that c squared there. So when I factor that GCF out, I'll be left with c squared plus 3a in the denominator. And the reason that that worked out so nicely is because now I can do some canceling here. There's a few things I can cancel. The first thing I can cancel is I've got a 15 over 15, but that 15 is a 2 times 15, so I'll be left with a 2, right? If I reduce the fraction 15 over 30, that's the same as the fraction 1 over 2. So that's what we've done here. With my a's, I can take one a away, leaving me with a to the first. I can take both b squareds. Can't do anything about that c that's there in the numerator. And then I have a c squared plus 3a in both places. So those can both be canceled. All right, so that becomes a 1 over 1 as well. So what's left after the end of this? Well, I've got a 1. I've got an a that's just become a 1, a b squared that's just become a 1, and a c over a 2 and an a. So really my final answer here when this is all said and done is c over 2a. And that's as simplified as I can make that one. All right, so really what we're looking at here is just use the GCF method. You're not going to be running into any situations where you have quadratics or cubics that you need to factor yet. Just start by pulling out GCFs and canceling out ones as often as you can.